for me, it's like less so about predicting the future and kind of viewing the future as like this thing that just washes over us. We have agency. We are the ones building the future. And so it's really, we need to say, okay, what is the future we want to build? And then try to actually be as deliberate as possible to build that and construct that kind of future, which is one of the reasons why I think like not only reading history is really valuable because it can be useful for like figuring out analogies, like where do the analogies work? Where do they break down? But also science fiction is really valuable because science fiction can give us a very large and deep and rich set of potential futures that we might want to aim towards. And which is to say, not every science fiction future is exact or realistic or right, but allowing us to see not just like cool new gadgets and technologies, but say like, how do these things, when embedded in society, affect the legal, ethical, regulatory, societal like what are all the implications of those things? Science fiction is really good at that. And so for me, it's much more, okay, like let's read science fiction. Let's think really deeply. Let's figure out, okay, what are the kinds of worlds we want to live in? And then work backwards and try to make those things as likely as possible.
Yeah. Hello again and welcome. I'm Eric Jorgensen and I have some very smart friends and I'm lucky to share them with you. Today, we're welcoming back an old friend, Sam Arbesman. He is the scientist in residence at Lux Capital. We first featured Sam on episode 63, talking about sci-fi and venture capital, and there'll be a little bit more of that today. Sam is also a frequent author. I believe this is his third book, newly released, called The Magic of Code. And that's kind of the core of the conversation today. We talk about how software has shaped the world. We talk about what software and sorcery have in common. I think it's an incredible metaphor. We get a brief lesson on the history of computing, which is fascinating. And then projecting forward kind of in the next 5 to 10 years of the AI revolution, how AI will impact everybody's day-to-day work, but especially venture capital. And my mind always expands when I talk to Sam. He's just my favorite kind of nerd's nerd. He's full of unexpected and interesting information, and I think you're really going to enjoy the chat with him. If you're considering writing a book like The Magic of Code, if you've been inspired by hearing Sam's career as an author, we would love to help. My day job as CEO at Scribe Media, we help busy entrepreneurs, executives, professionals write, publish, and market their book. We see a lot of people go through a career inflection point when they publish their book or grow their business faster or just kind of step into a new level in their industry. So if you'd like to chat about a book idea, what a book process looks like, what the options are available to you in Scribe or in the industry at large, please visit scribemedia.com and schedule a consult with my team. Now, I invite you to take a deep breath, relax, and enjoy hanging out with Sam on Smart Friends, arriving in your ears in 3, 2, 1.
Sam, man, it's good to see you. It's been a minute.
Yeah. Yes, it's great. Good to be talking to you again. This is a lot of fun.
How is life? Have you been wrestling? Was this book a beast, or did it come easy for you?
So, in some ways, I mean, it took a lot of work. I mean, every book takes a lot of work.
They all do. Yeah.
Every stage, you think you're kind of close to the end, and there's always so much more to do. But this one really, it felt very personal in terms of a lot of the topics and ideas that I've been thinking about for many, many years. Because it was really sort of, I mean, in truth, this is the kind of book that I wish I had when I was young and like first getting into computers. And I kind of had to cobble together all the different ideas on my own and over time. And so it's very personal. So in many ways, like this is the kind of thing I've been thinking about much of my life. But it's also a way of me kind of paying it forward to like future little Sams of like, okay, like when you're thinking about computers, hopefully this will now be one thing that will get you excited by it.
Yeah, I think those are some of the very best books. Like when you are writing for an audience of one, and it is like the inner child, and you
Totally.
know, it's sometimes hard to find the boundaries of those books when you have 20 years of thought about it.
Oh yeah, there was a lot of things that remained on the cutting room floor, which is just how it is. But yeah, it was great.
Yeah, I remember talking to you about the germ of this idea, the seed in a coffee shop in Kansas City in, I don't know, 2021 or something. Like,
wow. Okay.
It was very early, and I think you were still like, I'm always curious how the ideas evolve. But I think the first conversation I recall about it was like, you were like, software is magic. Software is absolutely magic. It's wizardry. It's sorcery. Nobody gets it. It's so much cooler than everybody thinks. Like, I gotta tell the story. I gotta tell the story. I gotta tell the world. Like, people need to appreciate this more. And I'm glad that like motif is the final, stayed all the way through. It's the magic of code. That's the book.
Right. There's definitely that through line. Like that remained. I really wanted to kind of convey that sense of excitement of like, right. And there is an entire chapter about magic and sorcery and computing and coding and everything like that. And of course, there's a lot of other things as well. But yeah, I really tried to kind of keep hold of that wonder and delight when, in terms of actually like trying to share it with my audience, which was great.
Yeah. So tell me that, like, that story. What is the magic that you see in software and computing?
Yeah. And so the way I kind of think about it is, I mean, like right now when people talk about computing or just tech in general, like I feel like there's this almost like broken conversation around computing and technology where it's like everyone's either like adversarial towards it, or we're worried about it, or just ignorant about it. And the truth is, all of those responses, they're not bad, but I feel like something's missing. And so going back to my own childhood, like when I think about my own childhood and my own experience, like first coming to computers, that it didn't feel that way at all. It was much more full of wonder and delight, and it also didn't even feel like computing or computation was this like, I don't know, branch of engineering. It really was, like when you kind of understand this stuff around computers and technology, it should almost be this humanistic liberal art. Like when you think about it, it should connect to language and philosophy and biology and art and all these different topics. And so that was the kind of things that I wanted to share in the book, of like the wonder and the delight. And of course the concern is in there. And I talk about those kinds of things. But when I think back to my own experiences with like our family's first computer, the Commodore VIC-20, or like early programming experiences, or SimCity and fractals and all these things, like that's the kind of wonder. And specifically also related to like the magic component. When it comes to magic, I mean, we've had this desire, like as a society, for millennia to kind of use words and text to coerce the world around us. And the truth is, until, I don't know, 75 odd years ago, whenever digital computers first became a thing, it really was just kind of a fantasy. But now it's real. We actually can use text and code to affect the world around us. And so that's one of the deep ideas that I want to kind of share, along with just sort of all the ways in which this magical stuff of code can touch upon all the different topics and ideas that I mentioned. And so actually going back to like the Commodore VIC-20, I mean, when this first computer that we got, it was early 1980s. I was really little. I didn't know how to program at the time. I would probably just like sit in my father's lap while he would like manually enter code from like a magazine or whatever that he was copying out, and it would make a game or something like that. More often than not, it would also create a bug, and like you'd get weird like gibberish on the screen. But I could, even though I couldn't program, I could see the relationship between, there was a relationship between text and what was happening on the screen. And I feel like that sense of magic and wonder of like, text affecting something, that really had an impact on me. And I eventually wanted to do it myself, and slowly but surely kind of got into the world of coding, which was a lot of fun.
Yeah, it is. It's fun to think through the whole history of, I can't remember who made this observation for the first time, but like that magicians and sorcerers and even fraudsters in that sense are like the father of science from a like historical perspective of like people created illusions and then had to engineer things that appeared like illusions. And then people were trying to figure out how that illusion got created. And it just sort of like cascaded into discovering like how the real world works.
Well, and I feel like there was definitely a period in, I don't know, like several hundred years ago, and for probably a long period of time, where there were these mechanical automata where people would make these things with like gears and various components or whatever. And some of them were like, they were fakes. Like, so like the classic one is like the Mechanical Turk, where it was like this like lifelike creature that was playing chess, and it would play at a really, really high level, and people were very impressed. And it turns out it was sophisticated, but also inside it was an actual human being who was playing chess. And then you have like some, I don't know, digesting duck that it would do all these things, and it was mechanical and very, very sophisticated, but inside it was not actually digesting the food. It was kind of taking the food in, and then there was like another compartment that was kind of pooping things out or whatever it was. But at the same time, though, there were also really sophisticated real things happening. And I feel like if you look also like at other scientific domains, like the transition from alchemy to chemistry, there was also these kind of like weird fuzzy areas. And so I'm not sure I would say it was like illusion and magic kind of as the thing that like led to science, but I definitely feel like there was kind of this interesting liminal period where things were kind of in between. There's this great story which it's kind of bonkers, but there was, I don't know all the details. My sense is, so there was, I think it was around like the early 1700s, maybe, where there was this woman in England somewhere who ostensibly was giving birth to rabbits, or they weren't live rabbits. It was kind of like dead rabbit parts or whatever. But it was in that weird in between period where people were like, okay, like science is a thing, but we also kind of believe all this other stuff, that there was a time period where like people were not sure, where like she was able to kind of hoodwink everyone. Of course, it was a hoax. It was not real. Like, she was not actually giving birth to rabbits. But the fact that there were kind of this in between period between magic and nonsense and science and technology, whether you're looking at like automata or alchemy to chemistry or weird things in biology. Yeah, I feel like we kind of think, oh, like the scientific revolution, like we put this like weird marker and like now everything from there is very easily understood. But no, there was this weird period where people were just kind of working stuff out. And it's a fascinating time period. A lot of the computing stuff came a lot later, but yeah, it's just fun to kind of see how people were kind of thinking about these things during this interesting time period.
Yeah, so that's a good segue, actually. I was hoping you could give kind of a brief summary of like the history of computing. I think it's one of these things that like most of us have lived in within just the silicon chip era, or at least are really only aware of that. And it's been long enough that people forget that there's like substrates of computing behind this that are like unlock huge things. And, we're likely to see another one kind of in the coming decade. So, but could you kind of trace that trajectory?
Yeah,
for
I
us?
mean, and so certainly there were a lot of ideas. So there's kind of like this very deep prehistory to computing as well. And so I would say in the first kind of modern digital computers were probably sometime like the 1940s. It's like around like the end of World War II. That's kind of like the point at which people say, okay, this is like the modern digital computer. But before that, there were all these precursors. So, I mean, you can go back really, really far, and like people were doing interesting things around logic and mathematics. But in terms of like mechanical things, like there's kind of like the prehistory in like the 1800s with Charles Babbage, who was doing sort of these mechanical computation devices, and he actually designed one. I think it was really basically just like a general purpose computer. I think he only ended up succeeding in building a very small component of it. So the thing was never actually built. Ada Lovelace was actually probably people often describe her as like the first computer programmer, because she took the design that Babbage had and actually developed an algorithm for it, and then kind of described it. Intriguingly enough, in the same way that like bugs kind of go along with software, her very first program had a bug, which is not surprising because she never actually had a chance to run it, and so she would have never actually known. But so there's kind of like that prehistory. There were like things that were kind of developed around like Boolean algebra as well. And then of course there was like the actual technologies that like, wires and cathode ray tubes or sorry, not cathode ray tubes, but like vacuum tubes and things that were used and repurposed for early computers. But then also before digital computers, there was also this very long period of analog computers. And the truth is, analog computers, they coexisted with digital computers for quite some time, because in many ways they were actually faster for certain special kinds of things. And so the way to think about an analog computer is, an analog computer is basically what it describes. The goal was to find a physical analog, like a physical analogy in the real world for whatever you are trying to calculate. So for example, rather than instantiating numbers as like amounts within like describe kind of symbolically described in like a digital computer of like, oh, like they're described in binary or whatever it is, a number would actually be described by some physical quantity. So it could be like the height of water in a tube, or the resistance in a wire, or something with a gear, or whatever it is. And it turns
a way to think about that, like an enormous automatic abacus, essentially, like sort a whole bunch of different abaci.
Well, and the truth is, so one of the most sophisticated kind of mechanical analog computers was this differential analyzer, which was developed by Vannevar Bush, who was also one of the people who like was responsible for kind of the development of the National Science Foundation, kind of like the big big government supported science. But he was also, I guess, a physicist or mathematician kind of involved in these things. And that one, it went through multiple different iterations, but it was this interesting kind of combination of mechanics and electronics, where it was, all these different wheels and gears spinning in certain ways. And that was related to this whole set of differential equations that you could kind of program by figuring out the specific relationships there. And then you could run it and it could do its thing, and you could simulate things very, very accurately. And it turns out there are still analog computers around now, but the big advance in kind of like the 1940s or so although it kind of depends who you're talking to about which one was like the true first one, was this idea of using electronics to represent numbers in kind of an indirect way, as opposed to kind of the more direct way of the analog computer. And then once you had that, although actually like the ENIAC, which was kind of like the first well-known digital computer, it actually did not use binary. It actually used, I think, decimal representation, if I remember correctly, for numbers. So binary is not required. Binary is, I think, just probably like the most logical thing, because like it's very easy to say on or off, 0 or 1, and then from there kind of work your way up. But then there were, so then after that, there was this advent of very large machines based on vacuum tubes, because this is before the advent of the transistor, which is basically another kind of switch, but it's a lot smaller. And so one of the reasons why transistors eventually gave way to, transistors took the place of vacuum tubes, is because they were smaller and they were more reliable. And so a lot of times, like these mainframe computers, they required you to like replace huge amounts of vacuum tubes, and there were lots of things going wrong, and it required like an entirely different building to cool these gigantic machines. And so these machines, they were huge, they were humongous. You can kind of like, they were room sized, if not larger. But the one interesting thing you mentioned in terms of like the early history of computing is that a lot of the things that we do with computers nowadays, our computers look completely different than those like room sized monstrosities. All those ideas and like the applications were almost there in like the very, very early days of computing. So like things around simulation, or I don't know, modeling, like actually trying to like embody ideas of living things in biology within computers. These were done in some of the earliest machines, or even things around like artificial intelligence. Artificial intelligence, like the inaugural conference around this was, I think, like in 1956. So which is like not that far after the advent of the computer. And so, and of course, it took a long time to percolate and to bake in, but now we have a lot more sophisticated things. But yeah, so there was this long period of mainframes, and then from there they kind of went to like, I think they were called mini computers. And so they were no longer the size of the room. They could just be, you had computers that could be the size of a refrigerator. So that was like a much smaller thing. Obviously, they're not a laptop. You're not carrying them around, or they're not portable, but they were smaller and easier to use. And so, and also around this time, people began to think about different types of like methods of input. And so like there were screens, and there were actually like a whole variety of interesting ways that people thought about using input. And so like there were early days around people thinking about like the computer mouse, but then also people came up with other ideas, and obviously keyboards made an impact. And actually, during the mini computer age, I think was like the first computer game. So Space War was the first computer game, and actually, even though it was like the first game, and you would think it's really, really basic, and in some ways it is. I played an emulated version years ago at some science museum, and it has actually a number of hallmarks of the kind of games that we have, where it was multiplayer. It was real time. There were graphics. It was visual. So it wasn't like a text-based game or anything like that. And my son and I had a great time playing with it. And like periodically, we haven't done it in a while, but we found an emulated version on the Internet Archive, and like we'd play it periodically because it was just a fun little weird game. And like you're like these two little spaceships kind of flying around and trying to shoot each other, and you can like go into hyperspace and jump around and do all these weird things. And just the fact that game was like the first game, but also had a lot of the features of games that we still have, is kind of wild. And so, yes, there was that period. And then, of course, I mean, we have like beginning in like the mid 1970s, late 1970s, that was the advent of the personal computer. So up until that point, computers were not things that individuals could really buy easily or have easily. So like the first one, I believe, was the Altair, which I think didn't even come with really many ways of inputting or even seeing output. Like it was like basically just a machine with a whole bunch of switches that were like the ways of like inputting like binary, like machine code, like just raw binary commands. Then you could I think you could add on a keyboard and a screen or whatever, but like the basic thing was really, really, really simple. But then, and then a couple of years later, that was, so it was 1977 was sort of the big year for personal computers, where the Apple II came out, and maybe it was the Commodore 64, and like the trash one, or Radio Shack one. I'm forgetting, but there were three personal computers that came out around the same time. And then people were like, oh, this is a real thing. The interesting thing, though, is there was this slight period between when personal computers first became a thing And when they became widely adopted, because they really needed like a killer app. They needed something that people were like, oh, it's not just fun for hobbyists. They needed something where people would say, oh, this is something I can use at home or I can use in the office. And the first killer app was VisiCalc, which was the first computer-based spreadsheet. So spreadsheets actually used to be real physical sheets of paper. And then Dan Bricklin and his co-creator, whose name is escaping me, they created VisiCalc, and it was this. And it was a spreadsheet, basically similar to the spreadsheets we have nowadays, and there were cells, and it doesn't look that dissimilar. And then people realized, oh, this is real. Like there's something here that people can really use in a very powerful way. And of course, yeah, then it kind of took off.
It's crazy. 1977. We're not even to the 50-year anniversary of the first personal computer.
Yeah. No. Well, so this is the interesting thing about computing history, I guess so. 1975. So then we are kind of we are at that point. So, well, I guess, yeah. So that would be, so we've just hit like the 50th anniversary of the first personal computer. The interesting thing about computing history is that for a lot of it, like a decent fraction of the people who were involved in the very early days, they're still around, or we have at least like their oral histories where like they knew they were getting older. And so they recorded all these things. So we don't necessarily have to just go through half remember or like letters or whatever. Like we have their stories, which is kind of wild. And actually there was one point when I was working on my book, there was a story that I had heard about where it was like people who were involved in like early computing and early AI in the 1970s. And there were like three kind of luminaries involved. And I wanted to check the story. And I realized one of them is still around. So I just emailed him and we had like a nice little correspondence, and he was able to like say, okay, this part of the story is accurate. This part, like maybe this is not quite right. But it was great because like the history is so young. That being said, the interesting thing with like computing history, on the one hand, many, many things have changed. And so like, I've been just talking about like the early personal computers, but like, of course, since then, like we've had graphical user interfaces, and now we have like the internet and the web and all these different things that have changed. On the other hand, though, we still have a lot of pretty fundamental things. Like, for example, like a Unix and its sort of descendants, they are still around. And actually one of the points I kind of make in the book, and so is like talking about kind of like the extreme age of Unix and its sort of brethren. So there's this great book by Neil Stephenson, the sci-fi novelist, but he has it's a small book called In the Beginning Was the Command Line, where he's talking about kind of like things around open source and graphical user interfaces and Unix, and there's all these different things. And one of the things he talks about is Unix as sort of the Epic of Gilgamesh of computing. And there's a specific reason he's talking about this. But one of the interesting things, and I mentioned this in my book, is that like, given the fact that Unix kind of came around almost within like the first third of computing history, and it's still around, like that's not the Epic of Gilgamesh. Like if you look at like the long span of human history, like this is older than Gilgamesh or cave paintings or whatever it is. Like this is something that's been around for a huge fraction of computing history, and we still use it. Like it's still like there are refrigerators that have Unix built into them, and all these other devices. And the fact that this was developed not like instantly within computing history, but fairly early on, and it's still so foundational, is kind of wild. And so, right, with computing history, it's both very short, and so you can barely talk about like multiple generations of computing history, but there's also been a huge amount of advances. And so, like just alone of like just the fact of like we look at like Moore's law and processing power doubling, like the kinds of things that people were doing back in the day are just unbelievably slow. So like I remember like I think our Commodore VIC-20 maybe had 5K of RAM, which is like something like a number that you can't even comprehend. And like I can remember our family's first, I think it was our first Macintosh, because we went from the VIC-20 to some like Macintoshes in the 80s. And I remember my father wanted to upgrade it to have, I think, like a 40 megabyte hard drive or something like wildly big, but now it's like, this is ridiculous. And it was this and I remember we had to watch this video to explain how to open, because it was like the single how to open the machine. Like, you don't touch this thing because it'll erase their memory, and don't touch this because it'll make like the cathode ray tube explode. And like it was kind of crazy. And it was all for 40 megs of RAM, or 40 megabytes of hard drive storage. And that's like it's a trivial number nowadays. And so yeah, just to think about how all of these things have kind of changed so rapidly is pretty humbling.
Yeah, I mean, going back to the sorcery and the magic of it all, the fact that you and I are live streaming a 4K video and perfect audio that is like as good as you sitting literally on my desk. And behind it all is ones and zeros.
Yeah.
Just like infinitesimally fast ones and zeros, and layers upon layers upon layers of, computing and software engineering that makes this feel effortless and reliable to the point where like it's basically a given.
Yeah. Well, and I think that layering, I think, is some of the most powerful aspect of computing. It's like one of the fundamental ideas of computer science is this idea of abstraction, that you can build very like more powerful things and more powerful abstractions and tools and sort of almost like computational concepts out of more fundamental things. And then once you do that, you don't necessarily have to think about the more fundamental things. So like, for example, when we are doing this, or when I'm not programming in Python or whatever, I don't have to think about binary. And the truth is, if I do think about those things periodically, it's almost overwhelming. And so it's like, oh, like we've had these like so many layers upon layers. And because of that, we can now build these unbelievable edifices. And it's only because of this sort of accretion of multiple layers of abstraction. And so it's unbelievably powerful. And it's also it's also interesting where, going back to like the magic and sorcery, I imagine very early on in computing history, it did feel magical, but it also probably felt really frustrating because of just like, you're just dealing with zeros and ones and machine code. And I feel like for me though, in terms of like when I came of age in computing history, because of those layers of abstraction and because of the certain types of programming languages that I learned. So like I actually neglected to mention like programming language. Like, right, there was a long period of like machine code, and then at a certain point we actually had high level programming languages. So Fortran was the first one, and now we're kind of saying, oh, we don't necessarily even need those. We can just kind of vibe code or whatever it is. It happens to be the kind of the time period when I came of age in learning about programming. Programming was incredibly powerful. It was incredibly magical in terms of like, here's this specific text and like I write this incantation or whatever, and it does something on the screen. It's amazing. But it also required a lot of work, which is not so dissimilar from the way people talk about magic and sorcery. I mean, like, yeah, you have to go to Hogwarts School for Witchcraft and Wizardry for 7 years to really be good at magic. And like, there's lots of stories where you have to train for a long time or apprentice or whatever it is. And I feel like I probably identify with that kind of thinking, especially so because of the time period when I learned about certain aspects of computing. And I imagine some people maybe before that might not have identified with it as much. And certainly some people after that might also not, because it could just be, oh yeah, it just feels, I mean, in some ways it does feel even more magical. Like I'm just having these conversations and software is being built for me or whatever. And so, but it's a different kind of magic too.
Yeah. When the engineering is so good, you can take it for granted. Like I'm a little behind you, but not by a ton. But yeah, it was enough to really understand how difficult it was coming before, and that like we had to build computers. If you wanted a cool computer, you had to build it. But now nobody opens devices anymore. Like you can't open an Apple device. You can't really spend much time on the OS of an Apple device. And so like you're being pushed almost up the abstraction layer.
You're being pushed, and I think also related to that, you're also being shielded a little bit from the vast complexity. So I remember this is years ago. It was when the Apple Watch first came out. There was this article, I think it was in like the style section of the Wall Street Journal. It was around whether mechanical watches are still going to be a thing, or whether or not like everyone's going to go the way of the smartwatch. And they interviewed this one guy, and he's like, of course. And the answer is, of course, people still buy mechanical watches. But this one guy was like, yeah, like of course I want a mechanical watch. I think of like the vast complexity of this mechanical watch as opposed to a smartwatch, which is just a chip. And I'm thinking like, just a chip, like this thing is like orders of magnitude more complex, but we've been shielded from it, or we don't have access to it. And I think, and so like going back to what I was saying of like the type in programs with the Commodore VIC-20, I saw like the relationship between the code and what was happening. And you can still do that kind of thing, obviously, with computers nowadays. But by and large, especially if you're not as technically savvy, you are shielded from vast levels of complexity until something goes wrong. And then you're like, oh, like bugs are kind of showing me a little bit of like the seams between things, for better or for worse. But you're right. Most people are shielded from that, or just don't realize the levels of complexity, or because of the design choices that a lot of these companies have made. Yeah, we are pushed up that level, like up these levels, and we don't necessarily have as much of an opportunity to dig into the innards of these machines. And people talk about this with like I was never really into cars, but my sense is like people who are like a generation older than me, they would like fix their cars, and it was very mechanical. It was very easy to figure, not easy, but it was like you could actually figure things out in a way that now you're using like computer diagnostics, and like the fact like cars are basically just like enormously powerful computers on wheels, where like there's like tens of millions of lines of computer code in them, which is really, really impressive, but doesn't necessarily have the same kind of, doesn't allow for the same sort of like mechanical, tactile ability to manipulate these kinds of things.
Yeah, those cars were built to be, repaired and maintained and restored by the user in a way that like, and computers used to be too, in a way that they're not anymore. And you're hitting on something that I think is very interesting, because I think I often say, like, thank God for Moore's law. Like, in an era of like decades of stasis, like this, what you are talking about, the compute and the software improvement, is basically the main area of technological progress for the last like couple decades. But at the same time, as you point out, we are shielded from it. And so people know that they get a better iPhone every couple of years. They know that they can stream video now in a way that they couldn't 15 years ago. But like, and that AI is maybe where that frontier is now, of like, oh shit, I didn't used to be able to do this. This is cool. But we're not seeing those improvements as much in other areas the way, imagine living through like humans couldn't fly, and now we have commercial airlines.
Well, and not only that, we've kind of, in some ways, like almost taken for granted some of these changes. And so when I'll tell a little story. So my grandfather, he lived to the age of 99. He was a retired dentist, but he was also a lifelong fan of science fiction. Like he read science fiction since basically the modern dawn of the genre. I think he read Dune when it was serialized in a magazine. Like he knew all the stories. And so when the iPhone first came out, I went with him and my father to like the local Apple store, and we went there and we're kind of playing around with the phone. And at one point, my grandfather says, "This is it. This is the object I've been reading about for all these years." And like, I feel like we've kind of gone from that moment of like, oh, this is an object of the future, and like really felt like the big F future, capital F future, however people describe it, to, I don't know, complaining about like camera resolution, or I don't know, just like the way I like random like little things.
Battery life.
Battery life. And you're like, come on, like this thing is insane. It's unbelievable. And on the one hand, that's good. It shows that humans are really good at adapting to all the change that's around us. On the other hand, it shows that we take all of these advances for granted. And so that even in the case of Moore's law and these things that actually have had unbelievable advances, most people are either shielded from them, or we just kind of take them for granted, or we just immediately start complaining about something that it can't quite do without realizing the fact that, oh my God, this is wild.
Yeah. The Wi-Fi in the airplane is too slow.
Yeah.
So what about the kind of the future of computing? Like, do you see us growing out of silicon in the near future? Like, what's your kind of rundown on future computing substrates? Do you see another, Moore's law continuing?
I mean, I'll say one thing. So first of all, I think I'm not that great at predicting the future. I feel like
That's a great start.
Yeah. So take everything I say and just kind of ignore it. No, but I mean, so actually I remember when my first book came out. When my first book was in 2012, and I remember being really
super complexity.
This is it was the Half-Life of Facts.
Oh, the Half-Life of Facts.
The Half-Life of Facts. And so when that one came out, I was really glad that it came out in print, because I was certain that like soon after that, every book was going to be electronic and there were going to be no print books after that. And of course, I was deeply wrong. And I feel like there's like other instances where I've just like totally missed it. And so I would say for me, like, I'm not necessarily, I can't say, okay, this specific thing is the future. I can kind of tell you like there are some interesting hints that I've noticed. And so in terms of like other substrates and things like that. So actually one of the chapters I have in my book is about kind of the similarities and differences between computing and biology. So, because if you look you're like, oh, like computing has binaries, has zeros and ones, and biology is DNA, and it's like 4 base pairs. So it's like 4 instead of 2, and it's like very, very similar. And like it turned out you can actually do some nice analogies. That being said, biology is also deeply different. Like it's much more stochastic and random. It deals in kind of like much more messy things, as opposed to like computers are made in chips are made in clean rooms. It's a very different kind of substrate. And some of the interesting areas that people are looking at are right now around thinking instead of thinking about biology as something wildly different, viewing it as no, like computing, like traditional computers and like the kind of computers we have like on our desks and things like that. That is a subset of this larger space of like information processing. And biology actually can show us all these other ways that that we can compute and we can kind of do these kinds of things. And so, because like people, we always are drawn to metaphors, analogies of like, oh yeah, like the cell is a machine or a computer or whatever. Like it is, but it's also a wildly different computer than anything you would ever use to compute with. But because of that, it shows us how much broader computing can be. So for example, like I mentioned, like harnessing randomness, that is like a very, very different way of operating. Or like, and people have actually used, I think, DNA to factor very large numbers or whatever into like their prime factors. But there's just also like, there's also another idea of, I think the term is polycomputing, where by and large in computers, like we have, okay, here's a function, it does this specific thing. But in biology, you can have an enzyme that can do like, I don't know, 3 different things depending on like the level of the biological hierarchy that you're looking at. And so it's almost like overloaded, like this kind of like specific things, like doing lots of different things. And that is a wildly different thing than the kind of thing we're used to engineering. But it shows how much broader computing could potentially be. And so for me, I love looking at like that kind of thing to point to, oh, maybe we should expand the kinds of ways we should be building chips or hardware or software or whatever it is. But also you have, I mentioned earlier, of like analog computers, and analog computers, like for many people kind of view it as like, oh, they had their heyday back in the day and digital computers kind of usurped that. And like, that's where we're going to go. But it turns out that analog computers actually can still be potentially useful for certain kinds of things. And there are chips that are more analog-like, that are specific. I think they're essentially analog chips that are designed for doing the kinds of calculations that are necessary for large neural networks very, very rapidly. So it turns out that you could potentially be using analog computing for training AI systems and things like that. And so for me, I love kind of seeing those little hints of like, oh yeah, maybe some of these ideas that we kind of ignored for a while, but are now worthwhile kind of revisiting could be useful as well. So there's that, like there's kind of like also the space of like neuromorphic computing, of like kind of using ideas from biology to inform how we kind of compute with neurons and things like that. Obviously there's things with quantum computing, which I think there's a lot of things that are moving forward in that. It still feels pretty early, but I'm excited that things are happening there. And going back to actually the history stuff, I actually think that we need, in terms of actually figuring out the next steps of like where we can build, like where the future lies, we actually need to spend more time thinking about the history of computing, because oftentimes there's been a lot of like paths not taken or things that were tried and were kind of ignored because the technology wasn't right yet. But we should actually be revisiting that. And unfortunately, at least from my perspective, Silicon Valley especially is like particularly ignorant of technological history, and sometimes like proudly ignorant, which is really not good at all. And like there is something to be gained from learning about like even just like looking at like computer magazines from the 80s and 90s or even earlier, like just seeing what are the things that have been tried to try to kind of revisit that, as opposed to saying, oh no, like the newest thing is always better, I don't need to look behind us. Because sometimes actually the things that people made, they should be revisited and they should be looked at. And so whether it's analog computing or certain ideas that have kind of been fallen by the wayside or whatever it is, I think those are also really valuable in revisiting, both first things around, and maybe not for Moore's law, but also just for the kinds of ways we should think about in terms of like new paradigms for computing or interacting with our machines, or thinking about computational tools for thought or whatever it is. Like, there's all these things that I think people have tried and are worth taking a look at.
Yeah, and the world of computing is, as you point out many times in the book, is like very broad, and we're seeing like very deeper and deeper specialization in types of compute and things that get built for specific outcomes in compute. Like the chip specialization, I think, is way broader than it ever has been before, which is cool. Yeah, I think there's, on the historian point, something I've noticed is some of the very best investors are actually incredible historians. You know,
yeah, no, I think knowing. Right, like knowing history is really valuable, and this is, and maybe I'm just partial to it because I find it really, really interesting, and I certainly included a lot of history in the book, partly because technology is moving so quickly that like I knew at least the history stuff was not going to be changing that much, and so I'll include more of that as opposed to like the most cutting edge thing. But I also really think that understanding it deeply is really powerful, but also recognizing that a lot of the things we're thinking about now, like these questions are not new. I mentioned before that a lot of the applications and the way we think about computers, they were around essentially since like the modern era of the digital computer. Like we were trying all these things, and it took a long time for some of these ideas to kind of reach fruition, but they're not new. And so like when you think about, especially like with AI, like people talking about issues around the alignment problem or unanticipated consequences, or how we think about how it will change the nature of work and meaning. these things are not new. And so like so Norbert Wiener, the developer of cybernetics, he has this, I think it was like it's in a collection of essays that I think was based on a lecture series called God and Golem Incorporated. It's a very thin book. And he talks about all these topics. And the truth is, not only was it like kind of in this weird, obscure thing where he was talking about like by the founder of cybernetics, but it was also in popular culture. So like around that same time, in like the mid to late 1960s, there was an episode of the original Star Trek called, I think it was called The Ultimate Computer. And it was about this like super powerful computer like being tested to like control the Enterprise and doing anything. And they talked about every topic we're talking about now. And it just, like, I remember watching that episode and just being blown away by how, I mean, obviously it's dated in many, many ways, but also how like perennially relevant all the things they're talking about were. And so I really do think that there's something to be gained, by looking at like how people talked about these things, how they thought about what they would do and how they would change society, and just like all that history I think is so powerful and valuable.
Through that lens, are you uniquely worried or not worried about like the alignment problem? And
so I'm not, well, I mean, I feel like there's enough people on either side that I'm certainly not unique, but and for me, the way I kind of think about how to think, I mean, less about the alignment problem, but also just kind of more broadly how AI is going to change society. I feel like there's also one easy way of exploring it is to say, oh yeah, like AI can do X, Y, and Z, but it can never do like A. It can never do this other thing. And that other thing is kind of the that is like the unique domain of humans. And of course, then like, I don't know, 10 minutes later, the AI starts doing that thing. And you're like, oh, I have to move the goalposts. And so, and this reminds me of within theology, there's this idea of like the God of the gaps, where it's like, oh, like, how do we define God? We'll define God as anything that science hasn't understood yet. But of course, science progresses, and through a combination of like cosmology and astronomy and evolutionary biology, we understand a lot more of the world. And suddenly, if you adhere to that idea, like your conception of God gets just narrower and narrower and narrower, and it threatens to kind of just evaporate entirely. And I feel like we do the same kind of thing with AI, where it's like, oh, like, and the truth is we did this even before AI, where it'd be like, oh, like humans are unique because we're the only ones that can use tools or language or whatever. And then we find things within the animal kingdom that show us that we're maybe not quite as unique as we thought. And I feel like we're doing the same thing with artificial intelligence. And so for me, it's less so around what is unique about humans, because I imagine like whatever we think might be unique might not be unique, and much more about what do we think is quintessentially human. Like in this case, it's more like, what is the thing that makes me feel most human? And that answer is going to be different for everyone. So sometimes it could just be like thinking really deeply about some idea. It could be gardening. It could be reading. It could be spending time with friends and family, whatever it is. Like, as long as you figure out what is kind of quintessentially human to you, and then make sure that AI and technology more broadly is not reducing your ability to do those things, but allowing you to do them in a better and richer way, then I think we're going to be okay. And because for me, it's much more about like ultimately all these tools, all these technologies and computers, like they were all developed for people, like, and they are meant to be for us. They're meant to be like in service of humans, as opposed to kind of the other way around. And as long as we think about that, and think about how we choose to adopt individual technologies and make sure they're kind of in service of making us quintessentially human, as opposed to just kind of cogs in some larger machine or whatever it is that we feel very unfulfilled with, then I think we'll be in good shape. In terms of like the concerns, I have, there are many concerns I have. I definitely think that when it comes to how we think about like work and purpose, like there are a lot of these issues. But for me, like going back to like the quintessential humanity kind of thing, I think we need to have this kind of conversation as a society, because right now things are moving so fast, and we are not really grappling with these questions. People grapple with them maybe individually or kind of at the margins or occasionally, but unless we really sit down as a society and say, okay, what do we want the future to look like? And so, like, going back to like me being really bad at predicting the future, for me, it's like less so about predicting the future and kind of viewing the future as like this thing that just washes over us. We have agency. We are the ones building the future. And so it's really, we need to say, okay, what is the future we want to build? And then try to actually be as deliberate as possible to build that and construct that kind of future, which is one of the reasons why I think like not only reading history is really valuable, because it can be useful for like figuring out analogies, like where do the analogies work? Where do they break down? But also science fiction is really valuable, because science fiction can give us a very large and deep and rich set of potential futures that we might want to aim towards. And which is to say, not every science fiction future is exact or realistic or right, but allowing us to see not just like cool new gadgets and technologies, but say like, how do these things, when embedded in society, affect the legal, ethical, regulatory, societal like what are all the implications of those things? Science fiction is really good at that. And so for me, it's much more, okay, like, let's read science fiction. Let's think really deeply. Let's figure out, okay, what are the kinds of worlds we want to live in? And then work backwards and try to make those things as likely as possible.
Yeah. It's tough to separate correlation from causation here, but like historically, science fiction has been a pretty good predictor, even over like long time horizons.
So I think I might disagree with that, only in the sense of I feel like so I would say because there's probably a certain amount of selection bias where it's like we are very good at noticing the science fiction stories that like nail it and be like, oh yeah,
but if you indexed every book from 1920,
right, versus like you look at everything, you're like, oh man, these are way off. So like for example, I'm currently reading I, Robot, like the short story, like the collection of like stories from Isaac Asimov. I'm reading it with my son, and the funny thing is, so like the book begins as kind of like the framing device is it's kind of stories being told by Susan Calvin, who's kind of like the robo-psychologist. So she was like one of the early people in like US robots, like the company that made the positronic brain and all the robots, whatever. And so they mention like her age and like when she got like her age and when she got her PhD or whatever. And like, I think she and I both got our PhD at the same year. And I'm like, I'm not like living in the future. Like there's no like robots walking among. I mean, that being said, maybe it'll happen in a couple of years. But like just like the like that was like wildly off in terms of the dates.
When was it written though?
So it was written in like the 1940s. Oh, I think eventually it was compiled in like 1950 or so. But like some of the stories were earlier in like the 1940s.
If it was written in the 40s and we're 70 years forward, and like he was off by 10 years, maybe 20. Like that's
no, you're right.
You're not off by 100%. You're off by like
fine.
30%.
Right.
Like that's a pretty.
That is true. So maybe it was just the fact that like it was so close to my own age, and I was like, this is freaky, and it also felt very like I was like, this is a science fiction novel. The other interesting thing is like you read a lot of these sci-fi novels, and they might be set in the future and like there's spaceships or whatever, but the society is clearly like the society of whatever time period it was written in. So it's like, oh, it's like they're way like hundreds of years in the future, but like the way like men and women interact is like clearly from the 1950s or like from like they're like it's far from the future, but they're clearly obsessed with the concerns from like the 1970s around overpopulation or like some of those kinds of things. And of course, like there's also many things that are wildly wrong. So like I mentioned Star Trek anticipating all the questions we have about AI, but like that story was still set like, I don't know, several hundred years in the future. There's warp drive, there's transporters, like there's a few things that are a little bit different. And so the interesting thing is like on the one hand, like we are nowhere near the kind of like space opera kind of stuff. But when it comes to information technology, we are far in advance of that kind of thing. So like, for example, I actually another time, another science museum that I went to, in it, there was actually they happened to have a special exhibit of like all the props and things from Star Trek like throughout the years. And I remember looking at like the flip communicator or like the pad that was used in like Star Trek Next Generation. And they looked like really, really crappy versions of things that we have now. So it's like, oh, like that looks like the iPad, except it's clearly just a piece of like poorly painted wood. And like, so and that's supposed to be like hundreds of years in the future. And so on the one hand, right, like we anticipated those things, but we were hundreds of years off. And then other things, we are nowhere near developing warp drive or whatever it is. So oftentimes people talk about science fiction as really, it's just kind of, it's a serious like set of thought experiments, or it's a great way of like discussing current issues in kind of this far future or kind of like counterfactual sort of way. So I definitely think there are lots of successes in science fiction, but I'm not sure I would view science fiction as a predictive success. I view it much more as like there is a whole like large set of science fiction stories and science fiction ideas, and we have the opportunity to kind of pick and choose from them, from like the kinds of things we want the world to look like. And so so on the one hand, yes, like the flip phone was inspired by the original Star Trek. Like I think there's like a clear story of like someone at Motorola who like created the track phone or like whatever the phone was, inspired by having watched Star Trek. And so like there are things like that where it's like not only is it like, did it become reality? But it was like inspired by these visions of the future. And then there are other ones where it's like, oh, you kind of got it right, where it's like, oh, like talking about the internet, or like, so people talk about like the metaverse, or like cyberspace, or whatever, like the kind of world of like William Gibson. And like on the other hand, like you read those things, you're like, this feels nothing like the web. And so like it depends kind of like how much you're squinting and looking at some of these visions of the future. That being said, I don't want to say this like take away anything from science fiction. I think it is enormously powerful medium, an amazing genre that I love, but I wouldn't necessarily view it as like the thing that is like best for prediction. And the truth is, like, when people try to kind of combine prediction and science fiction more clearly, where they're kind of like writing some sort of like futuristic stories or whatever, like, but like around like working with like a company or whatever, I feel like those stories kind of end up being the least interesting because they're not as like unfettered imagination. And of course, I mean, science fiction is, especially like hard science fiction, it's not completely unfettered imagination. It's not full on like, I don't know, swords and sorcery or whatever. But I view it much more as it can be inspirational, it can be guiding, as opposed to entirely predictive.
Yeah, interesting. As you look forward, like based on the research you've sort of just done and this unique kind of moment we're in, where maybe computers themselves are like, at least personal computing feels like it's maturing or reaching some sort of plateau. I don't know if you'd agree with that, but, and at the same time, AI is like, we might have just had our kind of 1977, like, oh my God, this is applicable to everybody immediately. Is it changing like how you individually are like living and working on a daily basis?
You mean AI, or just kind of these
Yeah.
these future? I have to say it's not changing my life maybe as much as I initially anticipated.
Is it on the same sort of like through line as a compute software AI? Do you see that all as part of the same sort of like story threading together?
I do. I think, I mean, AI feels, I mean, it certainly is a unique advance and very powerful, but in many ways it is part of kind of, yeah, this continuum. So like you look back to like early days of computing, where there was kind of this, and one of the major ways that people thought about computers were as tools for education, or ways for like allowing children to kind of more easily manipulate information, or as like computational tools for thought. And so in many ways I feel like AI is sort of like the real version of a lot of these kinds of things. And so like, for example, I also, and people for many years have dreamt of this idea of like like you basically describing a piece of software that you want, and then the computer basically building it for you. And for many years, that really was not so possible. This whole idea of like democratizing coding, like whether, and there was like the the Macintosh software HyperCard, which was fantastic, and I could talk a lot about that. That was like beginning in like late 80s, early, not like kind of like through the 90s, and it was this amazing medium for allowing non-programmers to kind of more easily become comfortable with building software and building things. And then you have like spreadsheets, which, I mean, if you're doing anything more than just like entering data in, like if you're using formulas or whatever, you are programming to a certain small degree, and that actually democratized things. But in terms of like powerful like no code or low code tools, there really wasn't that much. I mean, there were lots of attempts, but like nothing really quite broke through in quite the same way until a lot of this like generative AI sorts of things. That being said, I think like we're still not quite there in terms of like that end goal of like easily building software completely, because I think like right now we're still very much stuck in sort of like the chat interface, and like the chat interface is powerful, but that's not the only way to interact with our computers. In the same way that like when we went from like the terminal command line to like the graphical user interface and the desktop metaphor and things like that. And so I think we need newer ways, or just other ways of like thinking about malleable software or interacting with AI or whatever it is. And so, but again, I view that kind of all as part of this continuous conversation that we've been having around tools that allow us to kind of do our work better. So whether it's like the Xerox PARC vision of the office of the future, and like AI clearly is an extension of that kind of thing, or tools for thought, or like manipulating images and graphics and stuff like these are all things that we have been doing for decades. And AI is certainly allowing us to do them much more easily and much more powerfully. But I'm not necessarily sure I would view it as like, I mean, it is a step change, and like, but it's also, so I think there's both power in saying, okay, this is radically different, and we do have to actually grapple with this. So, and going back to what I was talking about, like quintessential humanity and how do we grapple with this. And so I think there's definitely power in that, but there is also value in recognizing that it's still part of this tradition of the ideas and this kind of like whole school of thought around how we think about what our machines are for. Because then, and going back to kind of like the combination of like the history and the future and everything like that, like seeing, like looking at that history of computing and seeing, okay, what have people tried to use computers for and how have they tried to interact with them? That can kind of ground a lot of the new use cases in kind of this tradition and make us feel a little bit less unmoored when we are grappling with these things that are objectively like radically new.
Yeah. Is the summary of all of that, those threads, compute, software, AI, essentially cheaper intelligence? Is it like what is the one sentence summary of like what this tool does for us?
Ooh. Yeah, maybe it's cheaper intelligence. Maybe it's processing information or understanding the world. To be honest, I'm not sure. I mean, I feel like when I think about computers, they are this general purpose kind of machine. And I feel like that is an AI is sort of this general purpose technology. And so maybe it's, I don't know, like just like thinking about kind of this continuum of like a Swiss Army knife for symbolic manipulation. I have no idea. That sounds terrible, but like that's kind of what it is. Cause like there's it, you can, cause there are, right. There's your work, there's your thinking about intelligence, but there's also like, and going back to kind of the early parts of our discussion around like wonder and delight, like there is this whole playful aspect of computing, whether it's like games, like actual like play, but also just, I don't know, creative coding, like building computer programs that kind of generate things that are almost like works of art, or just the very act of programming is this very human, idiosyncratic thing that can sometimes have like style and beauty to it as well. And so there's all of that too. And AI is changing those kinds of things, but there's also that. And so yeah, maybe it's this kind of, and maybe fundamentally it's, yeah, around like symbolic manipulation or manipulation of information for fun and for profit. I don't know. It's like better ways of of information manipulation for fun and for profit. I don't know. That's also terrible. But I don't know.
It's not a book title,
No, definitely not. But I think that kind of goes back to the fact that like computers are, because they are these weird like everything machines. Then not only are they kind of like general purpose in terms of like you can kind of like compute lots of different algorithms and things like that, they can be used for so many different use cases. It means it's hard to kind of distill down like what the computer is. But ultimately, I think of like, and going back to what I was saying earlier, like like our technologies and certainly our computers, like they are like, we need them to like, we need to make them work for humans and not like limit our humanity. And so whatever new era of technology, whether it's AI or whatever it is, like that we come across, we need to make sure it's kind of in service of that. And so, yeah, I don't know. But I guess that's one thing I always just think about.
It's really difficult to describe the universality. Like David Deutsch talks about that a lot, right? Like, there's two universal computers. It's like computers and the human brain that are like truly universal things. But when you use magic as your, or sorcery or wizardry or whatever it is as your metaphor, I think I'd be very curious if you add to this, but I think there's sort of two components that stand out to me that are very difficult to summarize without sort of appealing to the the supernatural, which is the universality that we're talking about. Like you can do anything with this.
Yeah.
And the fact that it's as near as makes no difference to zero marginal cost. Like that's the other magical thing. Like before computers and before software, almost nothing in the physical world truly has zero marginal cost to it. And we're still sort of having a hard time, I think, wrapping our heads around some of that. Like, what does it cost somebody who's listening to this podcast? Doesn't cost us, doesn't cost them, like maybe fractions of a cent of data transfer and energy. And that's just a thing that did not used to exist. That is marvelous and magical and wondrous.
No, I think that's a really good point. And like so one of the things I talk about of like the nature of code and just like software more broadly, or with this kind of like creative kind of component to it, is that like code, like when you build something with code, right? It's text, but it's not like a substance, but it's like it operates in the world. It's this very weird new kind of thing that we really don't know how to grapple with. And so right, it allows us to create things with well nigh zero marginal cost. It allows us to coerce the world and kind of this like magical feature of it. It has all these other kinds of properties, and yeah, and we don't like, and it's different. Like it feels radically different. That being said, I will say in terms of like the physicality, I feel like one of the interesting things around code and computing is that it is deeply physical, but we often forget that. We often forget it until something goes wrong, or it's like, I don't know, like some you're confronted with some crazy bug where it's like, oh, like the Wi-Fi only works when it's raining. Which actually there was like, I read this story about this kind of thing where it was like it made some tree branches wet, and then it kind of lowered something, and then it created a line of sight, and suddenly the Wi-Fi was working, but when it was dry, it wasn't raining. And so it's this weird thing where on the one hand, we have built this massive physical infrastructure that we sometimes ignore at our peril. Like the internet it's real. Like it is a thing. Like as
Series
much as,
of tubes.
so that's so there's actually a great book called Tubes, which is about the physical internet. Like saying like, no, that senator, as much as we made fun of him, like he was onto something. Like there is a physicality to it. On the other hand, though, because we spent a lot of effort and a lot of capital actually building out this infrastructure, we now have the ability, right, at the margin to just do things that are just costless and free, and allow us to, going back to like layers of abstraction, to not have to think about any of that. We don't have to think about the physicality and just be like, oh no, this is just like weird thought stuff kind of doing its thing, winging its way around the world. And that's wild. And I think, right, and that is something that in the grand scheme of human history has never really happened, where it's like we can now like tell stories to each other, but those stories can like, they can actually be valued at like billions of dollars. Like when you think about software and companies, like that's kind of wild. And so, and right, and because it's so new in the grand scheme of history, like we're still trying to figure out what that means and how we think about it. But that being said, even though it's still new, it's not static. Like we're constantly upgrading it and thinking about building new versions of these kinds of things, or now we add AI to the mix. And so we're in this weird place where like it's just like humanity is grappling with this. At the same time, we're just kind of like running to stay still, kind of like the whole like Red Queen kind of thing. Like we're just running as fast as we can to not just get like passed by all these new technological advances. And I think on the one hand, going back to what I was saying before, like humans are really good at adapting. So I think we will adapt to all this. The question becomes kind of like, at what cost? And that I think is the thing that we need to be a lot more thoughtful about.
Yeah. I feel like software is in an interesting place right now through like you and I both sort of dabble as VCs, if not more, but like, or certainly have many conversations about, how to place capital and where sort of things are going in the near term, long term future. And on the one hand, software investing has been a lot of what's happened for the last couple decades, and it's sort of almost emerging into its own weird little subset of venture capital. But also the AI explosion is happening. Like, did this change, did going through this book and sort of exploring this hypothesis, like, did it change how you think about where you emphasize, where you invest, where you focus for the next, 5-10 years? Did it reignite a love of software in you?
That's a fun question. I mean, so I'll caveat this all with, so even though I work for Lux Capital, I am not on the investment team. So I'm not the one kind of calling the shots in terms of like figuring out where we want to invest. That being said, in terms of thinking about the areas I might want to spend more time or kind of like direct maybe other folks be like, oh, like you might want to pay attention to this kind of thing. I definitely feel in the same way that early on in computing history, there was all these things kind of that people were playing with that now like it took like many decades, but now they're kind of at maturity. I like looking at the areas that are kind of in that same tradition, but also are still just weird, playful kinds of things. So it's like, and so oftentimes those are the kind of things that are not anywhere near investment yet, but it's the people who are just kind of trying to rethink what software is, or what are the kinds of interfaces that we want, or how do we think about, people use this term like malleable software or like democratization of code. Like these are the kind of things that I just want more of. And I would certainly say I definitely have spent a lot more time thinking about, certainly working on this book around the kind of like the playful aspects of computing. That being said, I mean, like the major caveat is like, those are probably not necessarily the biggest outcomes for venture, but I do think that's where you find unbelievable passion around like what makes computing. So like, for example, whether it's like there's this whole realm of like the poetic web, like the people are kind of viewing it like, oh, like there's the web that's like, I don't know, like SaaS and like enterprise software and like big websites and things like that. But there's also just like people building these like weird, quirky little websites, and they kind of call it like the poetic web, and like this, it's much more playful and delightful. None of those things are like huge businesses or like venture scale or anything like that. But it just shows that there's this other way of playing with these technologies. And it also shows that I kind of mentioned this, like the enterprise world or whatever, like the corporate world, which I kind of identify in the book as like this utilitarian stance towards technology. And then you have like the wondering stance, which is like the much more playful stuff. The thing is, it's not an either or. You kind of need both. Like whether it's the playful stuff and exciting people to get involved in it, and then eventually building the kind of things that are kind of more corporate, or the corporate stuff that then provides that higher level foundation to make it that much easier to build the playful stuff. And so for me, I love finding that intersection where people are building like people are building tools that are useful for a wide variety of use cases, including whether it's like business use cases or just a wide variety, but still incorporate the sense of playfulness and kind of open-endedness. So like one example would be, and this is it's a Lux company, so but so like TL Draw, where they're kind of building this like infinite canvas for like as kind of like a drawing tool, and like prototyping, kind of like you can kind of draw and map things out. But and so they're kind of building this as like, oh, like this is kind of this primitive that you can incorporate into whatever tool you want. So like if you want to build like your version of Figma or whatever it is, you can kind of use TL Draw. But they are also just building all these wild and crazy AI experiments for drawing and art. And actually there was one of them that came out maybe a year or two ago that I got my kids hooked on, and they just found it amazing to play with. And so I love that intersection. And so maybe that's the area that really has like some really interesting potential that I want to explore more. And it's a little hard to kind of like point to always or kind of or describe it fully, but that where kind of the utilitarian stance and the wondering stance meet, I think is where some of the most interesting things are happening.
Yeah, I mean, the wondrous is difficult to engineer your way into. It's kind of the series of like tons of diverse experiments that
Yes.
result in like, oh, that's actually really fun. Oh, somebody found out how to make a fun thing useful, and a toy turns into a tool. Do you have, you mentioned earlier kind of feeling like there's evolutions to go on what those UIs for AI are. Do you have an inkling of what that'll be?
So I don't know. I mean, I certainly think something more visual might make them like where you can kind of like manipulate things, especially if you're building software. I think just having conversation after conversation with an AI tool feels necessary, but not sufficient. Being able to kind of manipulate the result or change things visually or in some sort of kind of tactile way, I think could be very valuable. I mean, they don't really use AI, like kind of the LLM kind of AI, but like there's like some of the work that like Brett Victor does with like Dynamic Land of kind of using like actually like thinking of like a physical space as a computer. And so like there's also like Folk Computer, which is kind of a similar kind of thing where you actually have like pieces of paper that have code on them, and then those are programs that are being run. Then you kind of move the programs together, or you move other objects, and they all kind of interact in this very, very physical way. That feels wildly different. I don't know if that's the solution for kind of better ways to play with AI, but I just want more people to be trying really weird and different kinds of things, because yeah, I feel like we got too narrowly like shunted into like the chat interface, which is not bad. It was really powerful, but I think now we're kind of bumping up against its limitations.
Well, on the frontiers of, we're kind of seeing really interesting, like one of the breakthroughs that I feel like is still underappreciated is actually like cheap translation between different modes, right? Like it's really cheap to turn words into an image and an image into words, back and forth, back and forth, back and forth, or into code.
Yeah.
And so like what you can think about, it is omni input in some interesting ways of like, I actually want to like, sometimes I want to click, sometimes I want to tap, sometimes I want to like, delete or cross out with a pen on my screen. Sometimes I want to just talk to the screen and say like, move this here, move this there. Maybe sometimes I want to type or copy paste, but like it should be trivial to interpret whatever my intent is, and then translate it. Like the space of inputs should be going way up over the coming 20 years.
There should be the sense of like, oh, like the software should be agnostic as to what is the best way for you to interact with this thing. Like, what if you want a terminal and a command line, by all means go for it. If you want to use like graphical user interface, yeah. If you want to like, I don't know, scribble something on a piece of paper with a pen and then like hold it up to a camera and then kind of go for like do whatever works for you, versus kind of the software saying no, like no matter what works for you, these are like the 2 or 3 ways you can interact with it.
You have to speak my language rather than
Exactly.
the computer learning to speak whatever you're feeding it.
Exactly.
Yeah, I'm hopeful. I was just picturing as you were going through, thinking back through the sci-fi and sort of the history of computing. Like, I kind of want a weird new Clippy, like somewhere between Clippy and Cortana, like living in my computer that can like interpret, that I can have a conversation with, but that has like total control of everything in the digital world.
Yeah.
Like that is a really super powerful thing. I mean, you think about like Jarvis, Cortana, like whatever, all of the like, voice,
these voice assistants,
that are characters essentially,
right,
but also can manifest stuff,
Clippy
anywhere
2.0.
computationally. And
apparently, here it is. This is what we need.
I mean, if Microsoft wants to go viral, it's right there. Like, there's nothing we would want to talk trash about more than Clippy. That'd be a high stakes maneuver for Microsoft. If it was great, it would totally work.
I mean, the truth is, even as long as it weren't terrible, and people also kind of recognize that it was just like an experiment, I think maybe it could work, right? Or they just like release it as like a fun little joke, and then then people enjoyed it. But you're right, if they're actually trying to make it like incorporate into something that then they have to kind of do it a little, and there's a little bit higher bar for
April Fool's Day, and then over deliver. Like that's the the strategy.
I like that.
All right, so what's the transformation? This is always a question I talk with authors about all the time as they're sort of shaping and writing their book. But I think it's interesting as a way to sort of entice readers as well. Like, what's the transformation that you hope the reader goes through from starting this book to finishing it?
Okay, yeah. So I guess it kind of depends on the specific reader. So certainly, I think this book will be of interest even if you are comfortable with code and things like that, because I talk about enough random and weird topics, or at least kind of coming at them from a different sort of lens that I think it will be of interest. And so I definitely think that this book, whether you are, if you're an expert, I will kind of give you a broader sense of kind of maybe where you are situated in the world of computing, and recognizing, computing is actually this much broader thing than I might have realized. Or it could maybe even just rekindle that sense of wonder that might have gotten you excited about this kind of thing initially. More broadly than that, though, I also think that this is the kind of book that I hope people who are maybe software engineers, or people who are computer programmers, or kind of people involved in the computing world can give their loved ones and say, this is why I find this world so exciting. So, and those people they're not going to come out like knowing how to program. Like it's not a programming tutorial, but I'm trying to convey that sense of wonder and delight, and the sense in which, going back to what I was saying at the beginning of the conversation, that computing and computation, it can be this humanistic liberal art that when you think deeply about it, you should think philosophically. It should touch on ancient mythology or biblical texts or ideas around what the nature of life is or how we think about art, and realize, it can be this kind of all-encompassing thing that can be really exciting and fun to think about.
I love that. I love you. I love this book. I'm really glad you wrote it.
Thank
You're
you.
the perfect person to write it, and this book definitely needed to exist. I've really enjoyed it, and there's definitely people I will gift it to, because I think there's, I really love anything that gives people a greater sense of wonder and appreciation for the magic that has been all these hard-earned miracles that the engineers of hundreds of years have been building for us, and it's really. It deepens my appreciation for life, and this book has done that for me, and I hope can do it for many others.
Thank you so
much. You for writing it. Thank you for coming. It's always a pleasure to catch up and learn from you and get to hear, what's lighting you up these days.
Well, I really appreciate it. Yeah, likewise, this has been so much fun. I really appreciate it.
Where should people find you, find more about you, find more about the book? What do you recommend?
So if you go to my website, arbesman.net, so just my last name.net, you can find recent articles, the books I've written. The most recent book is the one we've just been discussing, is The Magic of Code. There's actually a website, themagicofcode.com, that it's a little website that I made. You can find it wherever books are sold. I also have a newsletter, which you can find on my website, as well as a podcast that I do through Lux called The Orthogonal Bet, where I interview lots of just really interesting, fun people about crazy ideas from SimCity to science fiction.
That's awesome. Also, I love that you have a .net domain. And
all
right.
Yeah, it's a pretty weird one. Yeah, but I love it.
That's what we're talking about. That's the layer, a sedimentary layer in the history of the internet.
Exactly.
All right. Good luck spelling orthogonal, everybody. Go subscribe to Sam's podcast. Appreciate you. Talk soon.
Thank you.